So using calculus, we can derive all these things. So we will get back to these equations again.
Okay.
But before we do that, let us recall the graphical derivation, right? Or what is the graphical? So yeah, let us talk about the graphical solutions. Oh, who has joined? Okay, there are lots of names, right? So the next topic is going to be a graphical solution. And then from that, we will understand that how we can derive. Right, so graphical interpretation or graphical solution. Right, so from graph, how we can understand different equations of motion, right? So before we talk about some graph, let us talk about straight line, right? And then let us talk about the slope of the straight line. So let's say we have x and y axis, right? So we have in graph, we have we have independent variable and dependent variable. So usually we represent the independent variable as x, dependent variable as y, right? Which is a function of x. So this is how we represent a graph. So let's say we have these two things. So one is x-axis, this is y-axis. So if we plot, let's say y equals to 3x plus 5, something like that. Right. So this is the equation of straight line. How this is the equation of straight line? Let us see that. So let us find out the different values, right? Different values. So how do we draw the graph? We take x and then we take y. So let's say we want to calculate x equals to 0. So this is x equals to 0. Y would be how much? How much is y? Yeah, this is the equation. So if x equals to 0, then what is y?
3 plus y, that is
Yes.
8.
X is 0, right? This is 0.
Yeah,
3
so
into
3 plus 5 is 8.
3 into 0. 3 into
Oh,
0.
sorry. Oh, sorry. 5.
Yeah.
Okay.
So this is 5. And then x equals to 1. Then this would be 8. And then x equals to 2. So then this is 3 to the 6 plus 5 again. So this is the, right, this is the thing. Now I cannot draw this thing in here, but let's try that. But yeah, so let's try this thing. So let's say yeah, so we have this y, and let's say this is right. So x is going from let's say this is 0. This is not 0. This is 1. So this is 0. This is 1, and then this is 2. We can have 3, 4, 5 as well, right? And this is, let's say, 1, this is 2, this is 3, this is 4, this is 5, 6, 7, 8, 9, 10, and 11. And let me write 12 also. So this is your one. First point is 0, comma 5. This is first point. So 0, x is 0, y is 5, this point. Right. Next point is 1, comma 8. So next point is 1 and then 8. So this is the second point. And then next point is 2, 11. So 2 and 11. This point. Right. So this is 2 and this is 11. Right. So this is 2, 11. So we can see that what kind of line is this?
It's a straight line.
Straight line, right? So this is a straight line. So this is yeah. So just think that this is a straight line, and because we don't have the axis, right? So let's say this is 2, comma 11. So this is a straight, right?
Yes.
Now, whenever we have a straight line, then we can find out the slope. And what is the slope? So slope of the line, it is represented as, let's say I'm calculating the slope in here. So I am calculating the slope from this point to this point. So this would be this distance, whatever this distance is, right? Let's say this is this distance and this distance. This is change in y and this is change in x. So this would be the slope. So what is change in y? That is y2 minus y1. And what is change in x? x2 minus x. So this is what? This would be 11 minus 5. And then this is how much? 2 minus 0. So this is 6, this is 2. So we see that this is 3. So slope is 3. Right. And we can see that this x coefficient is this slope. So this is how we calculate the slope. Is it clear?
Yes.
So important thing that we have to remember is the slope of the straight line. Whenever we have a straight line, so this thing is very important. Slope of the straight line is very important. Now we can talk about different graphs, right?
Sir, can you repeat it once again?
Yeah, so let's say whenever we have a straight line, right? Whenever we have a straight line, we make this graph of the straight line. And then we want to calculate the slope of the graph. So to calculate the slope of the graph, we take 2 points. Let's say this is x2 and y2. And let's say this is x1 and y, this point. So the slope of the graph is this thing, y2 minus y1, x2 minus x1. So change in y. This is the change in y, right? Because this is the whole y and this is this y. Right, this
Sir,
is
how is
y2.
that the x?
Which one is x?
I mean delta x.
Delta x. Okay. So you see that the first x is at this point. Let me zoom this thing. So you see that first x point is here.
Okay.
Right. This is, let's say, x1. So we are going from this point to this point. Then this is the change in x. Right.
Okay.
And this point is this one. So this has this y. This is the whole y. Right. And this was the initial y. Right. This is the initial y. Clear?
Yeah.
So change is this one. This is the change. Right. This is the change. Clear? If it is not clear, let me just make another diagram. Let me make another diagram which would be easy to understand. So let's say that yeah, let me make another diagram. And let's say we have a straight line. Let's say we have a straight line like this. Okay, this is passing from the origin. So let's say we have 2 points. We take 2 points. This one we know, and this one we know. These are the 2 points, right? So this will have, this is x, this is y. So this point will have this x, which is x1, and this point will have this y, right? So this is x1 comma y1 point. Is it clear?
Yes, sir.
And now this point will have this x, which is, let's say, x2, and
But
this
I'm not
point,
understanding from here.
yes.
I'm not understanding from here. Where are you? Like the second equation you're telling, right?
Yeah, second equation, what? Yes. What is not clear?
No, like from x to x2.
Yeah, so this point is here. So this will have some x and y, right? This point. Okay, so now let me again, yeah, so let me erase this one and then let me take a graph. So from graph, this will be clear. Okay. So yeah, so let me make yeah, these lines. This one. Okay. So from this one, it would be clear, right? So let's say that we have so let's say that we have some x-axis, some y-axis, and some x-axis. Okay. So this point is 0, comma 0, right?
Yes.
This point is 1, comma 0. Or let me write it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 1, 2, 3, 4, 5, 6, 7. Let's say this is x, this is y. So is this thing clear?
Yes.
Now, let's say that I have 2 points. Let's say I get this is 0. So let's say I get 2 points. One is 2, comma 5, and the other is let's say 4 comma, and let's say 5 comma, let's say 7. Right, so these are the 2 points that you have. Clear?
Yes.
So 2 comma 5 is where? This is 2.
Yeah.
In X part, Y is 5. So this is,
Yeah.
this is 2 comma 5. So
Yes.
this has X1 and Y1. Right, it has X1, Y1. Is it clear?
Yes.
And now we have 5 comma 7. So 5 is this one. Right, let me pick, because let me pick 1 comma 2. Right, this is, so let's change this thing. Let us pick 1 comma. Okay, I'm just picking some random numbers. So let's say this is 1 and comma 2. Right, and then
Yes.
5 comma 7, this is 5 and this is 7. So this is my 5 comma 7. This is 1 comma 2. This is 5 comma 7. So this is, I'm seeing x1 comma y1, because every coordinate, every point will have x and y coordinate, right?
Yes, sir.
So this I'm saying x2 and y2. So what is x2? So x2 is this distance, right? If I draw this straight line, so if I draw this straight line, so okay, so finally it is there. So now this is the straight line, right?
Yes.
And let's say I want to calculate the slope of this line. So to calculate the slope, I have to calculate the change in x, what is happening in x part. So this is change in x, right? This is change in x, and what is change in y? So this is change in y. Why am I
So
saying?
can you repeat this again? Can you repeat this?
Yeah, so this is a change in x, right? This is x1, this is x2. This is the x2, right?
Yeah.
And this is y1, and this is y. So this is x1, right? From here to here. Clear?
Yes.
And this is x2. Clear?
Yes.
X is 5, right? x2 is 5. So this is from here to here. And this is from here to here. X is 1. Clear? Again, not clear. Please tell me. Maybe I can repeat this thing again.
Sir, I'm not understanding how you are getting x1 and x2.
Okay, so whenever we have a point, let's say this point. This point will be some x and some y.
Yeah.
So x meaning that how much we have covered this distance. So this is x.
Yes.
Right, so this is x, this is x, this is x. So this
Yes.
thing is x.
Yes.
Now how much it has covered this distance? So this is y.
Y. Yeah.
So this is x.
Yeah.
And this is y, right?
Yes.
Now let's come to this point 1 comma 2. So what is x? X is 1.
1. Okay.
And this point 5. So what is x? 5.
Oh, 5. Okay. Okay, understood.
Right. So yeah. So this is how. Now,
Sorry, sir.
yeah. Why?
Continue.
Why? So this is you are clearing your doubts, right? So
Yes.
if the doubt remains, then it would be troublesome. So it is good that you are asking me all this thing, right? So don't hesitate. That is the rule of this class. So don't be sorry and then ask every little bit question, whatever
Yes.
doubt you have. So don't feel sorry about it. Okay.
Yes.
So now you understand that this is the change in x, right?
Yes.
This is the change in x because this is the total x. This is the total x, and this was the initial x.
Yes.
So this is the change. And what is the change in y? So this is the new y, right? This is y2 from here to here. This is y,
Yes.
right? Y is 7. So this is y. Y is 7. So this is y2. And earlier, what was y? Earlier, y was 2. This was y. Clear?
Y2.
Y2 is 7, right? Y2 is 7, so this is
Yeah,
7.
yeah. Yeah.
This is 7. Y1 is 2, so this is 2 in y-axis.
Okay.
Clear?
Yes.
Now, what is the change in y? So this is the change in y, right? This is the change. So
Y2
this is
minus
what,
1.
yeah, so this is what I am saying. This is the change. So this is
Okay.
the change. So this is y2 minus y. And this is x2 minus
Plus
x.
2 minus x.
So this is the change from x. This is the change from y. So to calculate the slope, we just write change in y divided by change in x. So y2 minus y1, x2 minus x1. This is, when I was talking about the differentiation, I talked about this thing, right?
Yes, sir.
Yeah, so this is the slope of the graph. How do we calculate the slope of the graph? We pick 2 points. So we could have picked these 2 points also. So this one and this one. Whatever point we can choose. So this would be the change in x, and this would be the change in y. So this would give us the slope of the graph. Clear? Is it clear now?
Yes, sir.
Okay, so this why we are talking about this slope, you will see. So yeah,
So do we
so
have to like draw the graph in our exam?
in
Graph.
the exam they will give yeah, they will give the graph, but you have to draw the graph for certain conditions. So let's say they will say that draw the graph of uniform motion. So then
Oh,
you
you
have to
just put a
draw.
line. That's all.
Yeah, so then you have to just yeah, then you have to just draw all these kinds of graphs. So now from
This kind is
graphical,
not there.
yeah, this kind is.
Not there.
Oh, so sir, yeah, your sir will do this graphical solution, right? Because if we are talking about the graphical derivation, so then this would be. Is it tough to understand? Is it troubling you? Yeah, is
So
this
no,
troubling?
just that I'm not very good at graphs.
Why? So graphs have x and y axis, and then you just draw the points, right? So let's take a very simple example. Let's take a very simple example. I want to draw y equal to x square. What is the graph of this thing? Right. So what I will do? I will find out what is x, what is y. So what is x? X is 0, y is 0. X is 1. What is y? What is y?
1.
1. X is 2. What is y?
4.
4. Right. And we can have minus also. So if x is minus 1, then this is 1. If x is -2, then this is 4. So this is the graph. We need 2 points, right? We need x and y coordinates to draw the graph. Now let us draw this graph. So let us draw this graph. So we have this thing. Oh. So we have this thing. And then we have this thing. So let's bring it here. It's nothing to us. Okay, so what happened to us? Oh, so this has hanged. Why is this? Okay, why this is not responding? So we have. Give me one moment. So let me just cut this thing and then start it again. Maybe we start the program. Oh, so let me share the screen. Yeah, so I hope it's working. Yeah, so let's say that we have all these points. Okay, so yeah, let's skip this thing. This is again, this has hanging. What is happening to this thing? Hmm. Maybe this ruler kind of thing, this background is yeah, creating this trouble. This has again hanged.
You can do in the normal.
Yeah, so okay, again should be. Hopefully this time it is not giving a sudden. So hopefully this works. So let's write this thing. So first point is 0, comma 0. So this is here, right? This is 0, comma 0. Second point is 1, comma 1. So let's say this is here, right? This is
Yes.
1, this is 2, this is 3, this is 4, 5, 6, 7. This is 1, 2, 3, 4, 5, 6, 7. And yeah, so the first point is 0, comma 0. This is 1, comma 1. And then we have minus 1, comma 1. So minus 1, minus 2, minus 3, minus 4. So minus 1, comma 1 is this point. Oh, this is minus 1. So minus 1, comma 1 is this point. And then we have 2, comma 4, which is this point. And minus 2, comma 4. So that is this point. So what kind of graph we are getting? So this is the graph that we are getting. Right. And this
Parabola.
is, yeah, so parabola. Right, so this is the graph that we are getting. And you see that why? Because we have this y equals to x square. That is why we are getting this graph. So to have the graph, we just need the points, coordinate points. If we know what is x and y, then we can draw the graph easily, right? Is it clear? Who's texting?
Could you repeat again what you just said?
So I said that to draw the graph, we just need the coordinate points, right?
Okay.
Okay, so now let us discuss what is the use of these graphs. So what is the use? Now I will remove this background because this is giving so many trouble, right? So let's yeah. So now we don't have any music. So now, what kind of graph do we have in this chapter? Right, in motion in 1D. So kinds of graph. So we have mainly two kinds. One is XT graph, and the other one is VT graph. What is XT graph? So XT graph is position time graph or distance time graph, right? And then you have this is velocity time graph, right?
Yes.
So do you remember? Do you remember how many kinds of motion we saw? We saw that speed has two types. One was uniform,
Yes.
and then other was non-uniform, right?
Yes.
So we saw this from the other point of view, right? Now from graph, how we can interpret whether the motion is uniform or non-uniform. Similarly, we found out acceleration. So acceleration was uniform and this was non-uniform, right?
Yes.
So using these two graphs, how we can identify whether the motion is uniform or whether the motion is non-uniform, right? So let us understand that. So let's say we have some data, right? We have some data. So let's talk about the distance time graph. So in distance time graph, let's say we have this data and this is t, this is x. So let's say at 0 second, this was 0. In 1 second, this was, let's say, 2 kilometers, right, or 2 meters. So this is in seconds, this is in meter. In, let's say, 2 seconds, this is 4 meters. This is 3, this is 6, this is 4, this is 8, this is 5, this is 10. So by looking at by just looking at this data, you can tell me that what kind of motion is this? What kind of motion is this? Yes.
So you mean in vector or in like that?
Vector? Why do we have any vector? We don't have any vector, right?
No.
Yeah. So we calculate the, right, we just write, let's say we just write it at this point, right? So this is the thing that we have understood, right? So this is A, B, and let me write it as 0, 1, 2, 3, 4, 5. This is 0 meter. This is 2 meters. This is how much? 4 meters. This is how much? 6 meters. And then this is how much? So 8 meters. And then this is 10 meters. So what is the speed in here? This is 2 minus 0, 1 minus 0. So 2 meter per second. What is the speed in here? This is 2 meter per second. What is the speed in here? This is 2 meter per second. What is the speed in here? That is 2 meter per second. What is the speed in here? That is 2 meter per second. Right?
Yes.
So is it clear?
Yes.
So by just looking at the data, what you can say? What kind of motion is this thing?
Uniform.
Uniform motion, right? So this is uniform. So we
No, I
expect
think
that.
you're talking about vector, or is it like a scalar quantity?
No. So that part is required when we have different directions. When we are talking about directions, we are in
Yes.
one direction only, right?
Yes.
So then we don't require this thing. So okay. So now let us draw the graph of this thing. So let us draw, and again I have to draw those right. So I don't know how we'll be able to. Let me draw this manually, but we will not get a straight line. But you understand that that is a straight line, right? So we will not be getting any straight line because we don't have that graph. Let's use that. Right? Let's see with that grid lines. So let me use this thing. Oh, this is very small. So what about this one? No, this is again small. So what is it? Yeah. So this is again very small. Let's use this one. Okay. So now we have this, we want to draw this graph. So we have x-axis and we have y-axis. Right. Now this is 0, this is 1, this is 2, this is 3, 4, 5, 6, 7, 8. This is 1, 2, 3, 4, 5, 6, 7, 8. Right, or this is going up to 10, 9 and 10. So this is B class. Right. Now, first point is what is the first point? So first point is 0, comma 0. So that is here. That is here.
Yes.
And then the other point is 1, comma 2. So where is 1, comma 2? This is 1 and y we go to. So this is 1, comma 2. Right.
Yes. Yes.
And then we have 2, comma 4. So this is here. We have 3, comma 6. This is here. And then we have 4, comma 8. This is here. And then 5, comma 10. So this is. So we can see that what kind of graph is this?
Yeah.
Straight line, straight line.
Straight line. Yeah.
So somewhat like yeah, nearly there, right? Perfect. So this is perfect straight line, right? And what kind of graph is this? So this is t in seconds. This is x in meters, right?
Yes.
And this is a straight line. So what we can infer? What we can infer that straight line represents straight line in xt graph represents uniform motion. Clear? Is this point
Yes.
clear? Now we want to calculate the slope of this thing. So let's say we pick any point. Let's say we pick this one and this one. Clear?
Yes.
So this would be the change in x, right? Is it clear? This
0
one.
to 4, right? Okay. Yes.
So these 2 points I have taken, right?
Yes.
So this would be the change in x. This would be the change in y. Am I correct?
Yes.
So this is change in y. This is change in x. So slope would be how much? Slope would be y2 minus y1, x2 minus x1. So how much is this thing? Y2 is 8, y1 is 4, x2 is how much? 4, and x1 is 2. So this is how much? This is 4 by 2. So this is 2. So this is 2 meter per second. So slope of the graph will give you the velocity. Clear? Is this part clear?
Yes.
Okay, so yeah, this is one data point. Oh, we have so much time, right? So yeah, so let's talk about the other things, right? So first we have understood that whenever we have xt graph and we are getting a straight line. So let's say I am getting this line.
Yes.
So without doing any calculation, you can directly tell me that this is what kind of motion?
So which one? The one which you
This
did?
graph, this graph.
Straight.
Yeah, straight line.
No.
So whenever you get straight line in the xt graph, then the motion is uniform motion. Is it clear?
Yes, sir.
Okay, now let's say I have another point or another data point, which is, let's say I have x again, this is new data, and this is 4, 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 this is 4. Right.
Yes, sir.
So what kind of thing is this? So what would be the data points? So the data points would be like this. So 4, 4, 4,
Oh, okay.
4, 4, 4, 4. Oh, how many? So this is the line that I'm getting.
Yes, sir.
Clear?
Yes, sir.
So whenever I'm getting a parallel line, in xt graph represents, so this x is not changing. So what is it representing? What would be the slope? What would be the slope? So this is representing rest. Represents object at rest. Is this point clear?
Yes.
Right, because the distance is not changing. It is constant. So this is a constant. Constant distance. Right. Distance is not changing. You are changing the time. Distance is fixed, which means that the speed is 0. Right.
Okay. Yes.
Because you can calculate the slope. You can calculate the slope. So this would be y2 minus y1, x2 minus x1. So you can pick any point. Let's say this one. This one and this one. So this is y2, which is 4, y1, which is 4, and this is 3 and 1. So this is 0 by 2, so this is 0 meter per second. So your speed is 0. Object is at rest. Is it clear? Okay, so I have made a mess of this thing, but I want to again draw one more. Let me draw another thing, right? In this graph only. And then I will write all these things in some. So let's say again we have a different data. Again we have an x. This is, let's say 0. This is 4. This is 2. This is let's say 8. This is 5. This is 10. Clear?
Yes, sir.
Now let us draw this thing. Let us draw this thing. So first point is this one. Which color? 0. So first point is this one, 0, 0. Next point is 1, 4. Right?
Yes.
1, 4. So this is here. Right? And the other point is 2, 2. So this is here. And then the other point is 3, 8.
Where
So
are you putting it?
yes. Yes, the green one.
Yes. Yes.
Yeah, did you ask me anything?
No, no, sir.
Yeah, so the other point is 3, 8, which is here. And the next point is 4, 5, which is this is 4, 5. This is 1. And then I have 5, 10. So 5, 10 is. So what kind of graph is this? This is going like this one, then this one, then this one, then this one, and then this one. So you saw what kind of motion is this one? Yeah, this is going like this, then this, then this, then this, and then this. So is this a straight line? Yes. Is
No,
this a
sir.
straight line? So this is representing, right, a graph which is not a straight line, represents non-uniform motion. Right. So these are the points that I wanted to make clear. So yeah. So please, yeah, please tell me if everything is clear.
Yes.
Okay, who's texting? Okay. So yeah. So what is the summary of this thing? What is the summary? So let us write the summary. So what is the summary? We have an XT graph. So the parallel line in an XT graph and parallel to what? Parallel to x-axis. Parallel line to x-axis. Right. In XT
Yes.
graph represents the object at rest. So this is the first thing that we understood. Second point is that straight line in XT graph represents the uniform motion. And the third point is curved line or curved line in XT graph or zigzag line shows the non-uniform motion. Right. And fourth point is that slope of the xt graph gives what? What does it give? Gives the velocity of the object. Clear?
Yes.
So let's say somebody will give you this kind of graph and they will write t and x, and they will say that this is the graph that you have. So without doing anything, you can directly say that this is what? What kind of motion is this?
Uniform motion.
This is rest, parallel line,
Yes.
right? So this is parallel line, so this is rest. And if somebody draw this graph, right? Let me choose a different color. So if somebody draw this graph, then what kind of this motion is this?
Uniform.
So this is uniform, right? And if somebody draw a graph like this, something like this, right? So what kind of graph is this one?
Non-uniform.
Non-uniform, right? Because this is not a straight line, right? Non-uniform, non-uniform. So this is the summary of this xt graph. Now we will come to the important part, which is the velocity time. So that I will do directly. And yeah, you know already because you have understood this xt graph. So we'll take the analogy, right? We will take the analogy. So let's talk about the second part, which is velocity time graph. And this has many applications. So velocity time graph gives the distance. This graph gives the acceleration. And what? So yeah, this is the graph used to derive equation of motion, right? Whatever we have done. So these are the three application of this velocity time, and we will understand it one by one. So first, let us understand what is. Let's say we are given some data points. So the data points would be. Let's say what is the data that we have. So we have. This is T and this is V. V is meter per second. This is second. So let's say that we have at 0 second, this is 0. Or let's say that this is 2 meter per second. Right. And then in 1 second, this becomes 4 meter per second. In 2 seconds, this becomes 6 meter per second. And then in 3 seconds, it becomes 8 meter per second. And then at 4 seconds, it becomes how much? 10 meter per second. So you can directly tell me that what kind of, now we are talking about not the uniform motion. So yeah, we can tell that what kind of motion is this one, right?
Yes.
Yeah, so we can calculate, right? Let us draw the graph and then we will understand. So let's say we have the graph. I will draw it directly. So this is 1, 2, 3, 4, 5, and 6. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have at 0 second, this is 2. So we are here. And then at 1 second, this is 4. So this is here. And then at 2 second, this is 6. This is here. 3 second, this is 8. So this is here. And at 4 second, this is 10. So this is here. So this is the graph that we will get. Right, again, so let's say this is the graph. So what kind of graph is this? Again, this is a straight line. Here. So this is a straight line. Straight line in VT graph gives non-uniform motion. Motion. Why non-uniform motion? Because speed is changing. You can see from the table. You see that speed is changing. Right? It is not 2 meter per second, 2 meter per second, 2 meter per second, 2 meter per second. So speed is changing. Clear?
Yes.
But what about the acceleration? So acceleration is, let's say acceleration in meter per second square. So this is 2 minus 0, right? Or let's say, yeah, in here we cannot calculate. So this is, in here, what is the acceleration? So in here the acceleration is 4 minus 2, 1 minus, so this is 3 meter per second square. From here to here, what is the acceleration? That is 2 meter per second square. From here to here, what is the acceleration? And from here to here, what is the acceleration? So you see that what kind of acceleration is this? Yes, what kind of acceleration?
Uniform.
Uniform acceleration. So good. So this is uniform acceleration. Oh, what is what? So this is the thing. So in XT graph, whenever you have a straight line, so that is uniform motion. But in VT graph, if we have straight lines, so that is non-uniform motion. But that is uniform acceleration. So is this point clear to you?
So can you repeat your voice? And
Yes, so are you getting some background noise?
no, this voice went out. Now it has come back.
Oh, so now it is clear. Okay. So what I am saying is that in XT graph, right, in XT graph, what did you get? So in XT graph, the straight line represented the uniform motion. Clear?
Yes.
But in VT graph, straight line represents non-uniform motion. So is it clear? Yes, is it clear?
Yes, sir.
And the straight line represents uniform acceleration. Clear?
Yes.
So I sense that you have some doubt, right? You have
No,
some doubt.
I understood.
Yeah, you understood. Okay. So now we can see that whenever we have a straight line, so this will have uniform acceleration and this will have non-uniform motion. But let's say if we have a data which is like this. So this is V in meter per second. This is, let's say, 3 meter per second, 3 meter per second, 3 meter per second, 3 meter per second. So now, and this is, let's say, 3 meter per second. So this is 3 meter per second. 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 So this is the graph that we get. Clear?
Yes.
So for this graph, this is representing
Rest.
rest. So you see the
Is it?
table. You see
No,
the table.
for XT it is rest.
It is rest.
For
Now
VT
for
it
VT,
is
it
not
is
rest. It will be
yeah. So
moving in a straight line.
yeah. So moving in a straight line, but what is happening? Speed is what?
It's constant.
Which is uniform. Clear?
Yeah. Yeah.
So you see that the idea changes, the meaning changes. In XT graph, the same thing is different in VT graph. So if you have a straight line, if you have a parallel line in XT graph, that represent rest. If we have a parallel line in VT graph, right, that represents uniform motion, right?
Yes.
And if we have a straight line in VT graph, that represents uniform acceleration, which is non-uniform motion. But in XT graph, straight line represents the uniform motion. Clear?
Yes.
So this
So can you just write the differentiation, like the differences, like in a table?
Yeah. I will write that, right? So
Yes.
I will write that part in. So I will write this sum, right? How much time? Okay, so do I
15
have to
minutes.
15 minutes? So I'm doing this graphical part, right? So that will take time. Yeah, let me update this assessment, please. So I will just update this in minutes. Give me 1 moment. So I have to update this thing, right? The portal. So, okay. Okay, so now and the final thing. So let's say the final graph is this one. This is the graph that we have. Clear?
Yes. Yes.
So this thing is what? This is non-uniform. What? Acceleration. Clear?
Yes.
And yeah, okay. So there is another point, right? So VT graph talks about the acceleration. XT graph talks about the velocity. Right.
Yes.
So let me write this thing in here. So the parallel line was V equal to 0. Clear?
Yes.
Straight line was V equal to constant. Clear? Uniform motion. V is constant.
Okay.
Right. This curved line represented V equal to y. Clear?
Yes.
Similar thing is happening in here. So parallel line represented A equal to C. Clear?
Yes.
And straight line represented A equal to what? That is why we are calling it uniform acceleration.
Yes.
And this non-uniform represented A is where. So this is how we analyze it. We analyze the graph. Is it clear?
Yes.
Okay, so now let us write the summary of everything. So let us write the summary. How much time do we have? We have 10 minutes, so we can write this. So in summary, what do we have? So one is xt graph. The other is VT graph. So in xt graph, if we have a parallel line, right? Parallel line represents v equal to 0, which is red. Clear?
Yes.
In this one, parallel line represents a equal to 0, which is v equal to constant, which is uniform motion. Clear?
Yes.
In this second one, straight line represents v equal to constant, which is a equal to 0, which is uniform motion. Right?
Yes.
In this one, straight line represents a equal to constant, which is v equal to vary, and this is also represents non-uniform motion, which is uniform acceleration. Clear?
Yes.
Now in this one, the third one is curved line. So in this one, v is varying, and acceleration may or may not be constant. So we cannot talk about this thing. So this is non-uniform. Right.
Yes.
And then the third. So in this one, curved line represents A is varying, which has non-uniform acceleration. So this is the summary. And the fourth part, slope gives velocity. In this one, slope gives acceleration. So this is the summary of xt and vt graph. Is it clear?
Yes.
Okay, so now, yeah, what is I will draw this thing in here. So this is x, and this is so this is t, this is x, and this is t, this is b. So again, let me draw this thing in here. So t and x, and t and x, t and x. This is t and v, t and v, and t and v. So we have this thing. This is parallel, so color has not changed. This is result. So this is this thing. This is this thing. This is let's say this thing. This is this thing. This is this thing. And this is this thing. This one is this way. So let's say this is the graph. So we are talking about this. This is this way. Let's say this is the graph. So we are talking about this delta y, delta x, delta y, delta x. So this should be delta x, delta t. So let me write delta x, delta t. This is delta v, delta t. So these are the summaries. Is it clear?
Yes.
Okay, now what is the use of this VT graph? So this is not in detail. We will talk about this thing in detail, VT graph. So the next topic is application of VT graph. So the first part is to calculate the distance. Distance and displacement. Right, so this is the first application. So let's say we are given some VT graph, right? And let's say that this is the graph, right? This is the graph that we have. Let's say this point, okay, so let me start from here. And then we will, so let's say this is the graph. Okay, so this is T, this is V, meter per second, this is second. Okay, this graph you are given. So how can we calculate the distance? Let us first talk about the distance. So the distance would be the area under this graph. So what is the area under this graph? So this is the area under this graph.
Okay.
So area under this graph, area would be distance, right? So area under VT graph gives distance. For example, let's say this is 0, 0. So this is 0, this is 5, and let's say this is 20. Right? So
Yes.
then what would be the distance? So distance would be area of triangle. Right? Because this is, let's say, A, B, C. So triangle ABC. That is the area under the curve, right? So
Yes.
what would be that? That would be half base into height. So how much is this thing? Half base is this distance, which is 5. Height is this distance, which is 20. So this is 10. So this is 15 meters.
50.
So this would be the distance, right?
Yes.
So this is first question. The other question would be how much time do we have? Oh, so we don't have any time. So we'll talk about this graph part in the next class, right?
Yes.
And you please again revise these portions. So because
Yes.
if you have some problem in graph, so yeah, we'll talk extensively about this graph. And whenever
Sir,
yeah,
for VT and XT graph, the things are opposite, right? Like
yeah, things are
one is
different, not opposite, but different.
different, like in the sense somewhat opposite also.
Yeah, the meaning, yeah, so the meaning changes, right?
Yeah.
Yeah,
Yes.
so yeah, so yeah, these are the things that yes.
Yes.
But in most of the cases, we will be using this VT graph, right? So
Yes.
yeah, so we just yeah, I have just also talked about this thing because from this one we can understand this VT graph, right? So that is why. Okay, so in the next class we'll be talking about yeah. So graphical part will be over, and then we can start this. So you can also start the free fall, and then this chapter will be over. So the free fall and relative motion, that will take 1 or 2 classes. So how much time do we get? So maybe we can, on Sunday, we can arrange again some extra class. So then this chapter will be over. What is your teacher doing in class?
He didn't teach anything today, so
Oh, so what did he do?
no, today was English teacher ceremony, so the whole day went
Oh,
in that.
oh, so there was some, but you have this next week, you have some, your exam, right?
Yeah.
So you just start your preparation now, right? Just
Yeah.
complete the dimensional formula and also this average speed and all those instantaneous speed, all those.